Example number 5. Find the limit of x cubed plus 2x squared minus 1 divided by 5 minus 3x as x approaches to negative 2. So we go back to number 5, theorem number 5, and we have that the rational function is continuous everywhere on their domain. So x cubed plus 2x squared minus 1 divided by 5 minus 3x is a continuous function on that domain. So the domain is all real number except for 5/3. So what all we need to do for this is that because we make x approach to negative 2, so this is defined on the domain. So what do we need to do is just plug in negative 2 into the function. And we evaluate this expression, we will get the answer is negative 1/11. Theorem number 7. The following types of functions are continuous at every number in their domain. We have polynomials, rational functions, root functions, trigonometry functions, inverse trigonometry function, exponential functions, and the log functions. Example number 6. Where is the function f of x equal ln of x plus tangent inverse x divided by x squared minus 1 continuous? Let's do one by one. Let's check the domain for one by one. Ln of x is continuous for x greater than 0. You remember the graph of the ln of x is this, right? The tangent inverse, this is a inverse function, and the graph of the tangent inverse is like this. So it's continuous everywhere. And then the x squared minus 1 is a polynomial. So it is continuous for all value of x. Now we have a rational f of x, which is the whole thing. The domain of f of x is continuous except for x not equal to plus minus 1. So combine all of this domain. So the tangent inverse and the x squared is everywhere. But the ln only take x greater than 0. And the function f of x cannot take x equal to 1 and negative 1. So it means that the function f of x will continuous from 0 to 1 and then union 1 to infinity. Example number 7. We want to evaluate the limit of sine of x over 2 plus cosine of x as x approaches to pi. So from the theorem number 7, sine of x is continuous everywhere. Cosine also continuous everywhere. 2 plus cosine continuous everywhere. Now the whole thing. This is continuous because it's the rational. And we find the domain of this. The domains of the function f of x is continuous. Is all real number, and that's why it's continuous all everywhere. Because in the bottom you see that 2 plus cosine of x. The cosine of x is between negative 1 and 1. So when you plug the value cosine of x, any value between negative 1 and 1, this will always give you the answer is greater than 0. So that's why the function f of x, which is sine of x over 2 plus cosine of x, is continuous everywhere. Then to find the limit, what do we need to do is just plug in pi to the x location. Now let's draw the unit circle. So we have this point and this point and this point. So we have pi, which is this point. Psi is 0 and cos psi is -1. So we have 0 divided by 2 minus 1, so 0 over 1 is 0.